All right, guys, your notes today are on independent and dependent variables. Before we begin, we have two definitions that I need you to know that's going to help you with your handout. All right, and they are domain and range. Domain is your X values, which is also known as the input value. And then range will be the Y values, that's also known as the output values on your input output table. So a variable is something that is changed. In scientific experiments, there are two variables. One that you control, which would be our independent variable, and one that is the result, which would be our dependent variable. The same thing is true for mathematical situations. The independent variable is the cause. This happens first. The one thing that is changed. On a graph, it is the x-axis, which we graph along the horizontal line. Okay, remember on our coordinate grid, the x is the horizontal. The dependent variable is the effect. So this happens as a result of the independent variable. So it's the result, what is measured. On a graph, it is on the y-axis or the vertical side of the graph. The dependent variable is changed by the independent variable. Dependent depends on independent. So y depends on x. Dependent depends on independent. So then when we graph it on our coordinate grid, which we only going to use the quadrant 1, okay, we're only going to use the positive coordinates. The x-axis will be our independent variable. The y-axis will be our dependent variable. So independent, dependent. So if you see these abbreviations, that's what they mean. So let's look at our example. So for our example, it says the county fair charges $1 per ride and an additional $3 to get in the fair. Write an equation to represent the total cost of attending the fair. So this example is going to talk about identifying the independent dependent variable, writing out equation, working with the table and the graph. So first, let's identify our independent and dependent variables. So independent happens first. So when we go to the fair, we have to determine how many rides we're going to ride in order to find out how much we're going to pay total for our admission. So independent variable will be the number of rides that we are going to ride at the fair. All right, so number of rides. Because each ride is $1, we have to know how many rides we want to ride in order to find out how much we're going to pay for the rides. And our dependent variable will be our total cost. So how much we pay for admission total, our total cost for admission. All right, so $1 per ride plus the $3 is going to give us our total cost. So with that being said, our equation is going to be y which represents our dependent variable, x is our independent variable. So y equals x plus $3. Okay, y is our total cost, x is the number of rides that we're going to ride. Okay, and that's going to determine how much we pay, right? So let's say we just wanted to ride one ride. Remember, it's y equals 1x plus 3. Remember that 1 is in front of it because each ride is $1. So x is our independent variable. Okay, x is our independent variable. The rule is the equation that we're going to use. So rule, equation, same thing. Y is our dependent variable. And we know we graph our ordered pair using XY. So let's say we only wanted to ride one ride. So that'll be 1 times 1. 1 times 1. So x equals 1. 1 times 1 plus 3. So 1 plus 3 gives us 4. So our coordinate would be 1, 4. Let's say we want to ride 3 rides. Okay, riding 3 rides means that we're going to pay 3 times 1, which is $3 for the rides, plus the $3 to get into the fair, which is going to give us a total of $6. Right? So our coordinates will be 3, 6. Let's say we want to ride 5 rides. 5 rides, $1 each is $5 plus $3 admission, which gives us $8, which gives us the coordinates 5, 8. Okay? Notice 5, 8. X, Y. 5, 8. And then let's say we wanted to do 8 rides. So 8 rides times $1 each gives us $8 plus the $3 admission, which gives us 11 total dollars that we're going to pay. So our coordinates are 8, 11. Okay. Remember, total cost, which is our Y, depends on how many rides we take. So Y depends on X. So now we're going to graph them. Before we do that, let me tell you that this is called an input-output table. Okay, your X is your input, your Y is your output. It's also known as a function table, and you will talk more about this in 8th grade. All right, so let's graph our coordinates. Remember, the x-axis is our independent variable. The y is our dependent. Okay, so x, y. So we said we were going to go over 1 because our first set of coordinates is 1, 4. So we're going to go over 1 and we're going to go up 4. So it's going to be right here. 1, 4. Our next coordinate was 3 and 6. So we're going to go over 3 and we're going to go up 6. Okay. Then we have 5 and 8. So 5 and then we're going to go up 8. And then our last coordinates we had was 8, 11. So we go over 8 and we're going to go up to 11. And you notice that all of my points are in a straight line. Okay, because y equals x plus 3 is called a linear equation. So all my points are going to be in a straight line. Okay, so those are your notes for independent, dependent variable. If you have any questions, please be sure to ask. Thank you.